Today I thought I'd do a show and tell of these two Gemini machines. Now they're both CP/M machines. There's this rack-based one which is a multi-board machine, got multiple boards in, and we have a Gemini MFB, MFB standing for multi-format BIOS. Now this is quite a special machine in that it will support up to 700 disk formats. So if you want to know what the UK's answer to the S100 bus was, and you want to know how these have direct lineage to what was probably the UK's first home computer, well, stay tuned. Well, before looking at these machines in any detail, it's probably worth trying to understand where these things came from. Well, there was a fellow called John Marshall who ran a company called NASCO, which stood for the North American Semiconductor Company. Now, despite its name, NASCO was a British company that distributed US semiconductors and other things. Now, John noticed in the US that suppliers there, semiconductor suppliers there, were engaging with the computer hobbyist community in order to sell more components. Now, John thought that might be quite a good idea to do in the UK, except there wasn't really a computer hobbyist community, at least it was very hard to find. So John's thoughts were, well, let's create the community and then I can sell them more components. To that end, John decided to build and sell a small personal computer, something that might cost around £200. So we got in touch with a fellow called Chris Shelton, who was known to be a bit of a whiz with microprocessors at the time, to design it. Now that machine was launched in the autumn of 1977 and it was called the NASCAM 1. The NASCAM 1 was a great success and they had to expand rapidly to cope with demand. Now that put a strain on costs and on cash flow, and eventually the company was taken over by Lucas Logic, but that's probably a story for another day. The 80-way bus used on the NASCAM allowed other manufacturers to create expansion cards for it. Now John Marshall went on to found a company called Gemini that did exactly that, produced expansion cards for the NASCAM. The 80-way bus used on these cards became known as the 80 bus and was probably the UK's answer to the S100 bus that was popular in the US. Now, apart from making traditional expansion cards for the NASCAM, Gemini also made processor cards. In fact, this is a processor card here. That meant they had everything they need to make their own computer systems. And this is one of them. This particular rack-based system uses the G811 processor. It's got a G812 video card. It has a MAP 256 memory card, which is not made by Gemini, but it is it's one of these manufacturers that supports the bus. And then there is a genuine Gemini floppy disk controller card. And these cards are all fitted into a Gemini G610 rack, a 19-inch rack. Now the backplane is a large piece of Veriboard. This is very popular. You could buy backplanes, but the 80 bus is so simple that many people just use the simple piece of Veriboard, and that's what's been used here. Now I bought the thing off eBay a few years ago as a non-working project, and it came really with the 4 cards and the rack. So all I needed really was a power supply, a keyboard, some disk drives, some software. Well, how hard could it be? I think it'd be fair to say that there were quite a few challenges along the way, mostly due to the fact that I knew a lot less about this stuff than I'd realised. I mean, the first job was to source a power supply, and in the end I just went with an ATX unit from an old PC, and it has all the necessary voltages, including a -5. Following that, I had to chisel some emulsion paint off a processor card. I don't quite know how that had happened. There were a few bent pins on the EEPROM, which is fairly easy to sort out, and some quite rusty pins on the PROMs. In fact, when I took one of the PROMs out, a couple of the pins fell off when I removed one of them from the socket. But I was able to use a Dremel to grind away some of the plastic packaging of the IC, and this gave me enough metal to graft on a couple of new pins. Now the biggest issue I had was a fault with the Intelligent Video Controller, the IVC. Now this thing wasn't really very intelligent at all. Trying to get it to produce any kind of display was pretty tough. In fact, it took a lot of effort from a lot of people, to which I'm very grateful. Thankfully, the processor card can be configured to work with a serial terminal rather than using a display card. So it didn't really hold me up in terms of restoration of the machine in general, but we did have a lot of challenges with that card. Now, full details of all this stuff are on the Glass TTY website, and I've placed a link in the description just in case it's of any interest. Now the machine is up and running now, and like I said, it was quite a journey. I didn't travel alone. I had a lot of help from a lot of people. To be honest, there's probably too many to mention here now, except to say a special thank you to John Hanson, to Neil Crook, to Nick Coleman and to Daniel Whitaker. Without them, I would have given up a long time ago. To get things up and running, I used a Gotek disk drive emulator. although at this point I didn't actually have any software. However, after a few messages on the computer section of the vintageradio.net forum, items started to turn up. So with some Python scripts and CPM tools, I was able to create disk images for the Gotek and managed to boot the system. Like I said, all the details are linked in the description. Now the keyboard was a little trickier. I couldn't source one anywhere, so all I could think to do was to create a PS2 keyboard to parallel ASCII keyboard adapter using an Arduino. Now this was a more natural route for me because I'm a software developer by trade and I'm probably better at software than I am at designing hardware. Having said that, it's not to say I'm any good at either. Now someone pointed out to me that the spec of the Arduino shows, on paper at least, that it's not capable of delivering enough oomph to be used in this situation. Fair enough. This has been running now for 3 years, so I'm pretty happy with that, and to be honest I never liked reading specs anyway. Things have moved on since those early days. It now has a couple of disk drives as well as the Gotek. It's using a later version of CPM which supports the quad density disks as well as the double density disks, and so I've got a lot more options for moving data around between those formats. It's all a bit Heath Robinson at the moment, although to be honest it's probably the neatest it's ever looked for a long time. I did think about making some kind of wooden cabinet for it or something, but to be honest I wouldn't hold your breath. I could always try and make something out of Lego, I suppose. Anyway, there we are. So as I mentioned before, these machines run CPM. However, this machine has an RPM monitor, so a monitor ROM called RPM. Now this was written by Richard Beale and it supports CPM programs directly, or at least it can. So only really where they are cassette based. So for example, if we had a CPM version of MS Basic on cassette, we could load it directly into the machine and run it under RPM without needing CPM at all. So there are two ROM monitor types that can be used in these machines. This one has RPM, as I mentioned, and the machine we'll look at next has a rather special version of a monitor ROM called Simon. Now the earlier versions of CPM that came with these machines simply supported single and double density disks. It wasn't particularly configurable. You would use the standard CPM disk utilities to create your bootable CPM disks and so on. Now this particular machine has since been upgraded to a BIOS version 3.5. Now with that comes a Gemini utility called Gensys, which allows you to configure the BIOS depending on what kind of disk drive you've got or what is required. Here we can see the utility Gensys. This reads a text configuration file that defines what base BIOS file to use and how to configure it, sort of to provide the disk drive support that's required. This makes it really easy to change. If you want Winchester disk support, you simply use the Winchester base BIOS file. I don't actually have that file because this was a floppy only version of CPM I've got here. But if I had that file I'd be able to just simply change it and suddenly have Winchester support. Now the multi-format BIOS machine we'll be checking out next takes this to a whole new level. As well as using Gensys to create a customised BIOS, there's a setup utility that can be used to map disk formats to physical drives. And with a number and types of drive fitted to the MFB machine, the approach allows for over 700 disk drive formats to be catered for. So let's take a closer look at that machine. Okay, with the lid of the machine off, you can see it uses the same type of cards as we've seen before, but mounted horizontally in a metal cage. There is a GM813 CPU with 64K of RAM on board, a GM849 disk controller, a GM832 Super Video controller. In addition, there's a Xebec disk controller bolted to the top, which interfaces the SCSI bus of the GM849 to the Rodyme 2015 MB drive. The machine is complete with 1480 track 5¼ inch drives, an 8-inch drive and a 3.5-inch drive. There's also a monitor and a keyboard. The machine was donated to me by Charles O'Brien. Now Charles ran a consultancy company back in the 80s called OBSYS. Now the machine needs some TLC, as you can see, however it's in fully working order with one exception. So turning the machine on, you can see the original monitor just doesn't work properly. However, thanks to Nick Coleman, I now have a circuit diagram, so who knows, it may get fixed before too long. So if anyone out there knows anyone who can sort this for me or can provide me with some pointers, well, please let me know in the comments. So let me pop on another monitor and we'll have a closer look at the machine. The CPM version that's supplied with this machine is similar to the CPM that we've just seen on here, except it has this multi-format BIOS option, where the base BIOS is a multi-format type that can be changed on the fly or pretty much on the fly. So there are a range of setup utilities and file copying utilities associated with this BIOS that allows it to support all the different disk formats. Now this particular machine is referred to as GM916. Certainly in the catalogues it was, and it would have originally been supplied with a GM829 controller and MFB1 software. However, when I got the machine, it had a GM849 disk controller, or at least a special version of it, something that had been modified for particular use with the MFB system. Now this was done partly as copyright protection. It was also upgraded to use MFB2 type software, which is a series of slightly different commands and so on. Now the reason I know all this is because the person who did the upgrade to this actual machine got in touch with me last year. His name was Daniel Whitaker, but more of that later. Now I was fortunate, I was able to test most of the cards that came out of this machine in this rack system here. And to aid with that I bought this kind of rack extender, which is quite nice. Prior to that I had to take the end panel off the case here and put the card as close to the end as I could so I could get oscilloscope probes on the end and so on. It turns out that most of the cards were basically okay. A decoupling capacitor fell off the disk controller when I pulled it out, but that was quite an easy fix. And there was a wiring issue on the back with the video connector, again a fairly simple fix. Now the processor card didn't work, but thank you to Nick Coleman, who helped me trace the reset circuitry, and it turned out to just be a faulty capacitor, so that was swapped and hey presto, we had a running system. Now one thing that wasn't working properly was this Rodyne 5MB disk drive. It clearly wasn't going round. There was some clicking noises coming from it when you tried to access it, but it wasn't rotating. Now I had some success with this SCSI emulator. I couldn't get the machine to boot to it, but I could get it to recognise it once I booted to a floppy disk. But in the end I didn't need it, because it turns out that Daniel Whitaker, the guy who, if you remember, contacted me after he saw my blog, and he was the guy that upgraded this machine to the MFB2 software. He worked for Gemini when he was 18 years old, and one of the jobs that he had was to go around customers' premises repairing Rodyne 5MB disk drives. It turns out that the motor power transistors tended to get lazy, whatever that means. But it turns out it's a fairly simple fix if you're prepared to take the drive apart. So I ordered 2 transistors, and with a few pointers from Daniel, 20 minutes after they arrived I had a working disk drive. Remarkably, it booted first time. Well, as ever, details of the process and those disk repairs and so on are all linked in, they're all on the website, and there's a link in the description. Now once the machine was booting, John Hanson helped me set up a serial network between this machine and his XBeaver emulator, which can emulate a Galaxy machine as well. Now he's got a product called TNet, which is a networking piece of software that runs over serial ports. And what that allowed me to do is image the hard drive. So I've got a complete image of it as a disk file, which is great. And that actually works with the emulator as well. So I've got a pretty good emulation of this machine using John's tools. I put links in the description to his XBeaver emulator and his other tools. I mean, they're awesome. You really need to take a look. If you've not seen them already, take a look at them. They're great. When I first got this machine running, I was really keen to try it with a disk that I've had for ages. So this is an 8-inch disc that I've had for years, and it's always been associated with this document. Now this is the Computer Literacy Project. It's a BBC document, clearly. It's the provisional content of the television series. Now I know this document is in the public domain, however this seems to be an early draft of it. And I've always assumed that this disc must be the source of that draft, but of course I've never been able to check until now. Now I don't know much about this disc. It's got I don't know if you can see that, it's got WS3 written on the top. So I kind of assumed at the time that this was a WordStar 3 disc, and therefore it's probably a CPM disc. And being an 8-inch disc, there was only really a couple of standards of 8-inch discs used back then in CPM. So I figured really I'd probably be able to work out what it was. Now in here I have descriptions of every one of the disc formats here. Which is crazy really when you look at it. There's 700 of them or something like that. Okay, so I'll just pop the disc into the disk drive. Put an MS-DOS disk in here. This machine has an analyze utility. Sorry, I'm stretching over the keyboard, it's a bit tricky. Let's have a look. We're going to have to check the 8-inch drive and see if we can find out what it is. Okay. Well, when I first tried this, when I first switched the machine on, I sort of guessed it was a CP/M disk because it had WS3 written on it. And I knew that IBM 3740 is a very popular standard for a single-sided 8-inch disk for CP/M. I ran Analyze and compared it with the IBM 3740 specification in this document, and sure enough it matched perfectly, so that's what I tried. So let's relive my excitement of trying this out for the first time. Okay, so the B drive, the A drive is the hard drive. The B drive, we've got set up as a QDDS, it's the quad density Gemini, I'm quite happy with that. So I press return. The C drive, well, we can have what we like here, but let's just have a double density drive. And you see how it's automatically picking up the 0, the mid 5-inch drive, because that's a high density drive for QDDS. That's the right 5-inch drive, which is for double density. D I've got set as the 8-inch drive, so that's the IBM 3740. And then we've got E, which I've actually got set up as a BBC DFS disk. And then F is our IBM 3.5-inch double density MS-DOS disk. So it's saying which system track do I want to match it to. Well, it's 0. We've got 2 system tracks, but we're only talking about SAC 0 at the moment. Oh, sorry, yeah, it's asking me for yes, of course, not for what the 0 is. Right, so that's done. Let's come out of, let's return to CP/M. That presumably is a warm boot, reloads all this nonsense. And if we do WIG, like, you know, what have I got, as we did before, we should see that we've got our drives all set up, which is the same. Right, so if I now go and have a look at DIR, was it D? Was our 8-inch drive. You can hear it whizzing up. In fact, there it is, and this is what I found when I first got this working, which was pretty exciting, really. They look like WordStar documents, I suppose. Who knows? So rather than mess about with the 8-inch drive and start trying to load them into WordStar or anything, I thought what I'd do is just copy them straight across, which is what I did at the time. And I used a product called MSUtil, which is on this machine. I think this is something that Charles, when he bought this machine, bought extra. But it's specifically designed to copy from CP/M to MS-DOS. So I don't know if you can see the screen very well there, but it's talking about copy files to MS-DOS, PC-DOS from CP/M. So we'll just do that. So which drive concerns the MS-DOS disk? Well, we know that's drive F. From which CP/M drive should the files be copied? Well, that's our 8-inch drive on D. Now it's after the file specification, and it was the BBC Computer Literacy Project .doc. There are other versions on there which I did have a look at. They seem to be versions that are building up to this particular document. So if we're happy, let's just go for it. Okay, well, there we are. Let's exit from the program, take it from there. Well, at the back of all this junk, we have a PC running DOS. It's actually DR-DOS, Digital Research DOS, but just the same. I'll pop the 3.5-inch disc in. Let's have a look at what's on A. Hopefully that's worked. Okay, there it is. So if we now run up WordStar, see if we can open that, because we thought it was a WordStar document. Oops, sorry. And there it is there. So now we have it on a PC, albeit in WordStar format, but that is its original format, so great. This actually seems to be a slightly earlier version than the version I've got printed. So there's possibly even another version of this as well. But there we go. Quite a success, really. It was quite exciting at the time when I did it first time. Well, there we go. So the only thing left really to show you is the 2 system tracks that exist on these machines. We've been working with System Track 0. It was System Track 0 that we were using when we were mapping the disk drive formats to the physical drives. We stored it to track 0, you may remember. There is also a track 1. We can use the boot command with a parameter of 1 to boot to system track 1. So let's just do that. As you can see, this is just a standard implementation of CPM, i.e. not a multi-format BIOS version. And I guess the multi-format BIOS version takes up a little bit of memory space. So if you wanted to run ordinary CPM software without all the overhead of all the different disk formats, then you could just boot to track 1 and maybe have a little bit more memory. This has clearly got a sub command here which is not working, but otherwise perfectly okay. Well, that's about it for this video. I hope you've enjoyed it. I hope it's been of some interest. There are links to the full Saga, including details of the PS2 adapter, the CPM tools and the Gotek settings. There's also a link to resources page with a whole host of software, disk images, ROM images and so on. There's also a list of magazine articles and any other publications that I found relating to the machine. Now, if there's anything you want me to add, just let me know. Well, like I said, I hope it's been of interest. If you've got any comments or suggestions, please feel free to add them to the comments below. Also, if you like the video, click the thumbs up and maybe subscribe, or maybe do all three. In the meantime, I'll say goodbye and I'll see you next time.